So the next one we're going to take a look at is y is equal to cosine of x. Alright, so again, looking at that unit circle, remember that the unit circle's coordinates are cosine, comma sine. So this time I'm going to be looking at my x coordinates. So where are my x coordinates pretty? Well, those square root of 3's over 2's and the square root of 2 over 2's don't look too appetizing. But those 1's and 0's, those are it. So at 0 radians, my x value is 1. At pi over 2, my x value is 0. At pi, my x value is negative 1. At 3 pi halves, it should be 0 again. And when my radians are 2 pi, I should be at positive 1. So remember, this is going to curve back down. And I try to make this as smooth of a curve as possible. And that's about as good as that graph gets. Alright, next one. Y equals tangent of x. So, quick reminder, tangent of x is sine over cosine, both of x. Alright, so common thing that we need to remember is that we can't divide by 0. So anywhere that cosine is 0 in our unit circle, we are going to get an asymptote to say, hey, these values don't work. Well, where that's 0 is going to be along pi halves and along negative pi halves. And again, asymptotes extend on and on and on forever, all the way down. Those are those x equals negative pi halves and x equals pi halves lines. And as you can see, this is going to happen every pi. So it would also happen again at 3 pi halves and negative 3 pi halves. But we only need to worry about one period. But since I've extended it out anyway, why not? Alright. And again, that's just because the period is 1 pi. So you're going to have an asymptote every length of pi. Not necessarily at pi, to clarify. Alright, so from here, important points. Well, at 0, I would get 0 over 1, which is just still 0. And then my next kind of pretty point, so the next pretty point that I would get would actually be at pi fourths. So I changed my axes a little bit. Sorry, guys. I actually went up by pi twelfths this time. So that way I can get to pi fourths and it's nice. Well, pi fourths would be, well, square root of 2 over 2 over the square root of 2 over 2. So anything over itself is just 1. So my other pretty point is going to be at pi fourths 1 and at negative pi fourths negative 1. And from there, it just approaches your asymptotes. It almost looks like a cubic function, but it is not a cubic function. And it would just repeat that process every single time. But again, it only told us to draw one period, so that's really all we need in our lives. Alright, let's keep stepping. So the next graph that we got is y equals cosecant of x. So remember that cosecant is just 1 over sine of x. Well, this is now an issue, because anywhere that sine is 0, we can't divide by 0, can we? So that would be actually an asymptote on every single one of these. We did not talk about this graph too much last year, so I'm not upset if you guys forgotten about this one. It's weird. So, go ahead, go find where sine is 0 and draw an asymptote. So my asymptote should be at every pi. If you're like, how the heck did I just get that? Well, if you need to, go back and draw that sine function. To be honest, drawing that sine function is about to make our lives a lot easier, so I recommend it anyway. So go ahead, draw a rough sketch. It can be in a very light pencil to say, hey, this isn't my actual graph right now, but go ahead, draw that sine function again for me, please. So if I know my sine graph, half the battle is over. So we've already drawn our asymptotes where my sine is 0, because anything divided by 0 is not happy times, because we can't divide by 0 again. So then I remember back from the first section, well, with reciprocals, all I gotta do is flip stuff over, right? Well, that's the same type of idea that's gonna happen to my graph. So instead of all of my points going down in this particular section, from this point, they're going to actually flip up. So again, instead of going down, it's now going to flip up. So, likewise, on this little piece here, instead of going back up towards that x-axis, I'm going to go from this point and go down. On and on forever. And it's going to happen here, and it's going to happen here. And that's your entire cosecant graph. It's weird, it's different, but it's there, and it's good to know. Or at least to see. Until then, let's look at the next one. So our next graph that we have is y equals secant of x. It's important to remember that secant is just 1 over cosine. So, just like before, it might be easier to start by drawing that cosine graph and then working from there. So let's draw my cosine graph. You can pause the video like I'm about to. Draw that cosine and then we'll work with it. So again, we can't divide by 0, so anywhere that I see a 0, I need to go ahead and put a dashy line to signify, hey, this is an asymptote. I can't have this value. So asymptote goes here, asymptote goes there. And then again, I'm just going to flip my pieces of my graph. So, because this is going back up on this piece, now it's going to be going down. And because this piece is going back towards the x-axis, now it's going to flip away from that x-axis. And same thing here. It's going to go through the x-axis and it's going to flip back up. Not my finest drawing moments. You guys already know. So there's that graph. So as you can see, if you know your guys' big 3 graphs, it's going to help you out with these reciprocal graphs as well. I'll see you guys in the next video to talk about cotangent, and then we'll probably move on to transformations. But until then, see you around.